Hello friends, welcome to my YouTube channel. And there are several process engineering topics, and I feel that one of the topics is the pumps. Pumps we deal with a lot actually. Whenever you want to pump the liquid at high pressure, you need a pump, and it is quite common in water service, oil service, or some kind of slurry service as well. So central processing unit pumps are very critical, and sizing a pump is very important topic. So basically, I'm just trying to release a couple of series of videos on pumps actually, and I'm trying to cover some of these topics actually. This topic is about parallel and series centrifugal pump operation, and see what is happening that I can prepare so many um, different PPTs, but to save time, I'm going through my materials which are used for PPTs. So these are the core PDF files from where we can create a very useful PPTs. I charge for presentation and webinars and podcast, but for YouTube channel, it's all free of cost. So feel free to subscribe my channel and subscribe it and do like my videos so that give me more encouragement to put several thousand of topics I have got on the process engineering actually. So I'm just trying to bring all these topics. So this topic is about parallel and series operation of the pump operation, and is a and let's understand the parallel pump operation. This is the combined characteristics of the pump operating in parallel is obtained by adding their individual flow rates for a given value of feed. So in the pump operation, basically we can see that the two pumps are in series, and the overall flow rate in the mixed header and the discharge header is the sum of the flow of through these pumps. So pumps with different pump curves should generally not operated in parallel. When this cannot be avoided, the pump with the lower shut-off head must be protected against operation at flows below the allowable minimum flow. The shut-off head of the combined pump discharge system is determined by the pump with the highest shut-off head. These are the some of the critical things that we should understand that what is happening here. And you can see this curve is like the shut-off head of the combined pump discharge system is determined by the pump with the highest shut-off head, which means that you can see this is the pump 1 and this is the pump 2 actually. These are individual pump performance. This is the H cube curve of the centrifugal pump. This is pump 1, this is pump 2, and you can see the combined head basically is like where you can see that the flow has increased, and subsequently the overall head is falling as a combined flow rate, which is increased because you are summing up Q1 and Q2, and subsequently the head is driven by the overall pumps, and this is the characteristic curve which is getting cut on the head actually. And this is the system plus head curve with throttling. This you can see this dotted line, and this is the Q3, which is the flow rate, and this gives you a different system head curve actually for uh, for the different flow rate actually. So you can see this is individual pump 1, pump 2, and head is there actually. So whenever somebody asks you how the combined curves looks like, the combined curve looks like a more flattened curve with two pumping operation. This is the combined curve of two pumping in operation. So again the same thing, you can see the pictorial representative of pump A and B, where this is system head is there, and HQ total identical parallel pumps operation, and this is the single pump operation actually. You can see that. So what happens that here the system curve was cutting at the lower flow rate as soon as the pump is combined, and you can see the flow has almost increased, and this gives you the combined curve of the parallel operation. So it can see it's more flattened and more widened across when we operate the pump on the parallel basis. Now there's a numerous reason actually. Let's go one by one. That capacity increase required for the existing pumps. The centrifugal pump may be combined into parallel operation for numerous reasons. The capacity increase increased for the existing pump service. Very high reliability is required for pumping service without total reliance on the function of auto start control mechanism. in order to meet the requirement for flow capacity higher than the normal. So that's why we use the parallel pump operation. Required serving capacity may exceed the routine energy supply available for the single driver or driver type. Many companies have low voltage or high voltage power supply cutoff at 160 kilowatt motor side. This multiple parallel pump may install to make each motor of low voltage. Correct. Desired for the operation flexibility or in the power supply or type result in a multiple pumps with the different driver types. The use of multiple pumps may allow investment saving. For example, three pumps may require lower or total investment than two pump size of 100 degrees. So it saves cost actually. For parallel pump operation, the head capacity curve is done by adding the individual pump capacity at a given head. Pump with different head capacity curve will have different flow rates. The process engineer must retain certain that one pump is not backed out or forced to operate below its minimum. So mostly in the parallel operation, two identical pumps are advised. And some more things like when pumps are operated in parallel, it is imperative that their performance curve rise steadily to shut off. A drooping type of performance curve gives two possible points of operation, and pumps may oscillate between these others and cause surging. Okay, so this is an important point for the parallel pump operation. In parallel operation, additional pump can be started up only when their set of heads exceed the head developed by the pumps already running. Okay, the pumps operating in parallel should have shut-off head 10 to 12 higher than the rated head, which is API 610, as per the API 610. So hope it is clear, which says, again we read this line, in parallel operation, additional pumps can be started up only when their shut-off heads exceed the head developed by the pumps already running. I hope this is clear, this statement. Okay. Then more about another difficulty may occur as a result of inadequate engineering suction lines, such that one pump suction steals from the other. The remedy to design an equal suction head and to ensure that available NPC is sufficient to satisfy each pump. So again, this is some of the actions we have to take when we are designing the parallel pump operation. It is advisable to provide piping bypass system so that their pumps can be operated without the other. Aside from flexibility, a bypass system permits operation under reduced condition during maintenance inspection and their pumps. Just more lines for the parallel pumps. There is a caution which talks about pumps in parallel operation, and we will read through this one, and then we'll come to the series pump operation. So what it says that a problem that occurs with the pumps in parallel is shown in figure 3.3. This is 3 point in parallel operation. You can see pump A and pump B are there, and what it says that two pumps are never exactly alike. If two pumps are installed in parallel, one pump may take more than half of the total flow and other pumps less than half. This is one of the caution when you operate a pump in parallel. Pump with a lower flow rate may be operated below its minimum acceptable flow rate. As the figure shows, the head produced by the two pumps will be identical because they are connected to the same process. If the head produced by pump B is lower than the produced by pump A, the situation shows uh, in the figure will occur. Pump B will decrease its flow rate until it can produce the same head as pump A. So you can see this is the actual pump B, target Q, and actual Q pump A. So basically, when two pumps are in parallel, the problem is that one pump can have more flow, other pump has lower flow, and the second flow pump if can reduce the flow so that the head can increase and matches with the other pump actually. So that's the problem with the parallel pump operation. If two pumps are normally identical and both driven by motor, the two head curves can be assumed to be within 3% of each other. If so, one can make a worse assumption that this head of the pump B is 3% lower than the head of the pump A. Then using the system operating condition, plot the flow through both the pumps. Make sure that the lowest flow rate is not below the pump minimum flow rate actually. So what it means that in no condition that pump B should be at the lower flow rate than defined by the vendor, because that means that it can damage the pump and it's more like on the left hand side, which you don't want, which is more like coming on the shut off head pressure actually. So 3% is the ideal condition where the two head flow rate differences can occur actually. So hope this is clear actually. And in this one head of both pumps, you can see there's a difference in the head, and slightly the pump we will try to match pump A by reducing the flow, and the target is that it should be between the 3% of the flow. Okay, now now we are in the series pump operation. Series is like, the flow rate is constant but the head increases because the two pumps are running in series actually. Okay, and let's go through some of the lines here. That the combined characteristic of a pump operating in series is obtained by adding their individual head for a given flow rate. So that's very true. And the shutoff head of the combined pump discharge system is determined by adding the shutoff heads of the individual pumps. Note that NPSS is generally a key design consideration for the first pump only, since the first pump acts as a booster to the second pump in series. That's well understood that C can pump 1, pump 2 is there. This is the heads of the pumps, this is the Q, and you can see the combined one, the see how the boost in the head is there. Because the first pump is helping the second pump, and second pump is getting boosted from the first pump, and that's the reason the combined head is increasing. You can see this raised head. Okay, the flow overall remains constant. You can see this is shown by the dotted line here. Very good. Now pump may be designed to operate in series. Why? The head requirement, the differential pressure requirement is low through the time, then several pumps in series can be turned off, and in transmission pipeline, the primary pump has a higher pressure requirement. Therefore, a low head booster pump is installed to pressure the suction of the higher head pump. Plant feed. So basically, NPH requirement, primary pump has a high NPCR requirement. So what happens is that you keep this pump in the second and the first pump, boost the NPCHA, and it is above than NPCR of the required for the second pump. Two or more pumps are preferred over multiple stage pump for erosive slurry operation. So I don't want to damage a single pump, so they'll provide two more pumps actually. Again, guys, you can see this is the single pump operation, and this is the two identical pump working in series. Actually, you can see this raised head actually, and some more lines we will study through. It's important that adequate suction pressure is available for all the pumps, which is common for all the pumps, especially to first pump in series operation. If the first pump in series system is deprived of adequate NPSH, its capacity may be reduced until NPSH are equal to NPSHA. Though there is a margin, then the capacity through all the pumps in series will be reduced, resulting in significant overall flow loss. What this means actually is this means that it is important that adequate suction pressure is available for to all the pumps. So basically, the first pump which is working in the series with the second pump, this is quite obvious that you need to give a proper adequate suction pressure. Otherwise, you can have a problem with NPSHA, and you need to have some margin within NPSHA and NPSHR, so that there's no cavitation or problems with the pump suction. And that's his line is saying that if a pump in a series system is deprived of adequate NPH, its capacity will be reduced until NPCR equal to NPCH. Then the capacity of through the pump in series will be reduced, because these two pumps are in series. So if the first pump is underperforming, the overall pump system where the two pumps are in series will going to have a low flow rate. Sorry. Okay. Now, there are some cautions that water pumps in series can have while designing a pump in series. What to keep in the mind that two pumps in series will generate much more discharge pressure than one pump alone. That's very true. In some cases, this pressure might be greater than the design pressure of the downstream piping or the other equipment, which should be avoided because you don't want to damage the pipelines in case of blocked outlet condition. Okay, this condition must be checked before proceeding with an installation of two more pumps in series. That's very correct. It's important to check the design pressure at the condition called pump shutoff pressure, which we already do because all the process engineers should to design to see that shutoff pressure doesn't increase the piping pipe what we call it pipe rating pressures actually. Okay. Then says that the shutoff pressure is obtained when the downstream control valve is closed and the pump operates at zero capacity and maximum head, which means the pump head moves towards left. Okay, so this is very much clear that you have to take care that the downstream pressure, design pressure, which is within or equal to the pump shutoff pressure. So again, it's saying that this situation is not allowed. Which situation? Which is like design pressure lower than the pump shutoff. One remedy is to install a safety valve discharge for the second pump as shown. You can see that this is some of the safety valve. So mostly in a brownfield where you can see that pump shutoff have increased, the design is low, so you try to put up SV so that you don't kill these lines. You don't have a condition where these lines are broken. See, pumped in series with a safety valve in discharge, for example, suction pressure 0, max shut-off 0, delta P 60, 100, max shut-off P2 60, discharge pressure PSC 120, at shut-off 120, design pressure 150, 150. Okay, so this is the condition. You can see this design pressure is less than pump shut off, so that's the reason this PSV is given. So hope you liked my this video for the pump series and pump parallel operation. I'm planning to put more videos on pumps actually, so that there's a clarity and engineers can break to also they can reply in the interview questions that if there's a parallel and series pump operation questions are there. So thanks for watching. Do subscribe my channel and do like my channel, and this will encourage me to put more videos actually. Thanks a lot for watching, and stay tuned for more such videos on pumps. Thanks a lot.